this one is combination. It's very similar to one Ian and I just did, which was all combinations. Check that one out if you're interested. It's basically like you take this union of things in, but instead of them being a union like they were in all combinations, it's going to be provided as a tuple. And what you pass out is a union of strings that are space delimited combinations of the things in that tuple. I think the space part is a little, esoteric or something, but yeah, Ian, where would you start with something like this?
Also like repeated values don't repeat, which I guess kind of makes sense with the way that unions are like deduplicated, right? Interesting. Okay. What would I start with? Good question. So T is going to extend
string. Yep.
String array. Right.
Perfect.
And then.
So broadly, we got to take a step back. This needs an accumulator, right? Because there's no other way to hold state while we do kind of like iterations. So one way or the other, we're going to need an accumulator. And your options are basically like you can make an accumulator that's like like a string or something, or you can make an accumulator that's like a string array and initialize it to an empty array. In this case, can I give you one hint? Because I would never have figured this out. This part.
Yeah, absolutely.
Okay. I thought you'd say that. I struggle, if anyone's curious, I struggle like hell to do some of these, and this one was a real tough one. The solution is not that crazy, but I think getting there takes a bit of gumption. So we can trivially infer the value of u because it's a string array. So let's look at this. T is the input. It extends string array. Great, we got that. U is a value is the type of a particular value of T.
Right. One of the elements.
One of the elements of T. Right. And the accumulator is being initialized in the very beginning with that one of the elements of T. So if we went in here and we said, okay, it's always good to kind of split these things out and see what they look like. So type x equals this and then number. We can see what it looks like. So this is a union with foo and bar and baz as three elements of the union rather than an array or a union, or I'm sorry, a tuple. That's the word I'm looking for. And if you're interested in this, Ian and I did one a little bit ago of these challenges called string to union. And this is the solution to string to union is exactly that. Okay, so we have our union. That's the accumulator. We're starting it off with that. Then we need to do something with the accumulator from there. Where would you suggest we start?
Well, I wonder if in the past, like we took like the head and the tail, right? We'd like take the first element off and then, sort of recurse over something. So there's going to be some kind of recursion here, it seems like. And we're going to need to like pull elements off.
We do need, so like broadly the structure is going to be like x extends y. We don't know what those are. What does it even say? Iterator yield. What is an iterator yield result? Okay, I'm not going to look. If you type y, control space, look at that. Okay. We have our recursion that's going to happen here in the truth branch, right? Somehow pseudocode. We're writing pseudocode, and then okay, let's think here. Well, we're gonna have to do like we can do empty string. I guess is empty string in the list. I don't know what we would put here. Let's try never. I don't remember. Let's try that. Okay. So broadly, that's where it starts. We know that just like in the before case, we're always going to start with, like, we saw that if we pass in foobar baz, we get, at the very first iteration, we get this union. So at least we can say that we're going to pass in that union here. You know, like we need to, oops. There we go. So at least we know we're going to pass in that union here.
Right.
Then the question comes, like, we're going to do something inside of a string. We know that, I mean, this is the recursive case. So
right.
Combination, we know there's going to be like something going on in there. As for what this part is, I'll just show you. It's ACC extends string. So if we get a value out, it's not a string. We don't care about it. We would like to avoid it. I don't know if we can avoid this. I thought there was a test case that forces this, but we can come back to this part and see if we can just do this all along. Mm-hmm. Anywho, combination. So all we need to answer now is like, what are the values that we put in here for like 1 and 2?
So 1 and 2. Like, I'll be honest, I am still just a little bit lost.
It's all good. So let me type it in here. We
need a space somehow, right? Like we're gonna need to join them with a space. That part's a little bit interesting.
Right. I should have shown that first. So there it is.
There you go. Yeah.
We put in our accumulator and we have our space.
Okay.
Then the stuff that comes next after the space, so because we're kind of like building it up, we have, look, foo bar happens a couple times. Like we see foo and then foo bar and then foo bar baz, foo bar, foo baz bar. Like, so passing things through like this, it's going to fan out. And, but what we want to make sure is that for this particular iteration, when it goes deeper, we're not repeating values like you said in the beginning. And to do that, we have to exclude. For anybody that's interested, this is a built-in, but exclude is another TypeScript challenge that we did before. In my reading of the rules of the road here, it's totally legit to use a prior solution that we spent the time to go through and figure out. Ian and I did exclude a few minutes ago in a prior. You can look back in the videos. So if you want to see how that works, go take a look. We're excluding, let's go look at exclude, right? Exclude from T those types that are assignable to you. So we're excluding from the accumulator those types that are assignable to this particular value. This is the reason, okay, I'm just looking at it now. This base case needing to be passed in this empty array is the reason why I think we could do this and then flip it. It would probably read better. There. Oh, we can't, sorry. We can't do that because then we can't use the accumulator. It only has to, that's a rule of TypeScript. It only can be used in the kind of truthy clause. So, okay, anyway, we're saying we're forcing it to say the accumulator extends string. Yeah. There's nothing, the value of an item of an empty tuple is never. So ACC, so this is like saying never extend string, it'll go to never. All right. I'm talking a lot. Ian, where are you at? A painful place.
So so why are we passing in the empty array again? Remind me, because we're
passing in the empty array so that we trigger this case. The empty array, it will always, if you say empty array extend string, it will always be false.
Right.
So we get never.
What if we need more levels here, right? Like, how is this?
In that case,
feels like it's handling the end case, right?
Right. In that case, we're passing in the accumulator as the second value. We're cheating here, right? Because notice in the very first case, we don't have any second value of the generic that we're passing in.
Right.
So we're cheating by passing in a U the second time only. We could probably better do this with a helper type. And actually, you know what? Let's just jump in, even though we're over our heads already. Let's jump into an alternative that I found. So this alternative does some of these things in different steps, and maybe it will make more sense. I have one more alternative after this. But so combination, T extend string rate, that's all the same so far. This one is using trim right. Trim right is a challenge. Ian and I didn't do it together, but someone else did it with, I think it was Upender and I did it. Trim right is being used here to infer the values from, like, they're inferring white space out of this. And we're grabbing all combinations, which was done in a prior example. This is the one Ian and I did together, and it uses is never in this case. It's a little different than the way that Ian and I did it, but it's basically the same. So it's grabbing an array of, or a tuple rather, of all of the possible combinations, and then it's lopping them together with this trim right thing. And that allows it to make sure that it gets rid of a trailing space at the end. Mm-hmm. It's kind of inventive. I don't know.
That's kind of cool.
Still crazy, I know. I'll disable that, and I'll show you the last one. In fact, let me grab this person's name. I wrote it down. We're gonna have to zoom. I try very hard not to zoom out on any of these things, but maybe, hopefully you can see it. I'll talk you through it if you can't. This one combination does the whole thing, and you see all the tests pass. It has the T, it has an accumulator, which is initialized to what we were calling U, which is just a particular value of that T. And then it has this union thing that it's building up. So the accumulator is it's ORed with the accumulator in the beginning. This is kind of what we were trying to do, or what I was hoping we would do. And then union, it's saying, does union extend any? I have no idea what the hell that means. If someone would like to explain in the comments, please do us the favor. Then we put in that the beginning, the union part, which again is initialized to what the same value of the accumulator is the first time through. Then we pass in the combinator. We pass in T, which is a difference, the original T, and which is funny because it's not really ever used except for in this position. So I think we could probably, let's look. Can we make it? Yeah, it doesn't even need to be anything there. It just needs to be something that satisfies the criteria, which an empty array will. So this T is not ever really used. Then it's saying if the accumulator extends the union, return never, meaning stop. We're at the end of the iteration, or keep going and pass in that accumulator if it doesn't.
Yeah.
We're into
cool.
like, we are fully out of orbit into outer space TypeScript land now, I realize. But yeah, well, those are some solutions. Ian, what do you think? Do you hate it yet?
No, I don't hate it, but I'm very glad that others out there have made these kinds of helper functions, and either they're in the standard TypeScript library, or there's lots of other open source repositories that have
like I use Typefest
a lot of these
and
kinds of things in it. Yeah, exactly. So I'm glad that there are smart people who can do these kinds of things.
Here. Well, to all the smart people doing this stuff in the world, thank you. We are happy to look at your solutions. Okay, see everyone later.
Thanks.